In this video, we're going to discuss a second test that can be used to discover or find local maximum and minimums, and this is called the second derivative test. And so again, what we want to do here is we want to find all the critical points of f of x. And then we're going to think about what's happening at those points graphically. And this first point says if f double prime of p is positive, then the function is a local minimum at p. And the reason is, what you want to think about is this is showing that at that p it's concave up. So let's think about that graphically. If we had some function that had this shape, and let's say we had this point A. Well, obviously that point is a minimum, and what we're showing is that at that point it's concave up. So if you have a slope of 0 and you're concave up at that point, then it has to be a local minimum. So here I would say A is the location of a local minimum. And so the opposite is true for a local max. If it's concave down at that point, then essentially what you're going to have is a maximum. So graphically, let's say we had this function. And at this point, x is b. And I would say b is the location of a local max. And so what determines that ultimately? Well, if it's concave up, like in this example, the second derivative is positive. And if it's concave down, like in the example on the right, the second derivative is negative. So now we're going to use that second derivative test to find the local min and max. And we've actually already done this with this function, but we're going to see how the second derivative test would work here also. So the first thing we need to do is find the critical points, the possible places for local min and max. Now we know that's where f prime of x equals 0. So solving this equation similarly like we did before, we know the first derivative is 3x squared minus 18x minus 48. And if we set that equal to 0, we solved that equation by factoring, and we got x equals 8 and x equals negative 2. And again, that's coming from that previous video and using the factoring. So what the second derivative tells us is if we plug these into the second derivative, we want to think about if it's concave up or down at those points. So the second derivative is 6x minus 18. So at x equals 8, we want to see what's happening. F double prime of 8 equals 6 times 8 minus 18. F double prime of 8 is positive 30. So what that means is that x equals 8, the function is concave up. If the function is concave up at x equals 8, then x equals 8 is a local min. Okay, so now let's try x equals negative 2. So if I plug negative 2 in, that's 6 times negative 2 minus 18. F double prime of negative 2 is negative 30. And so what we've shown here is that at -2 the graph is concave down. So it would have this shape. And so what that shows is that x equals -2. That is a local max, which matches what we had previously done with the first derivative test.